I'm Fiona Lightfoot, and this is my Physics 2011 Physics Lab 4 on oscillations. So, the purpose of this lab was to investigate the motion of a spring mass system with an oscillating spring. So, we used Tracker as our software to track the motion of the object and get points for its position. We used GlowScript, which is a computational model to predict a graph for the motion and the energy changes. The main purpose and goal of our experiment was to determine whether the model follows the energy principle. And the result I obtained was that the system's total energy remains a constant at 0, therefore demonstrating the energy principle. So to go over some key concepts, we have Newton's second law, which is the system's external forces are equal to the change in momentum divided by the change in time, which you can see in my first diagram, which is F net is change in momentum over change in time. We also have F net is equal to the force of the spring and the gravitational force added together, and they will cancel out. And then we have F net equals minus Ks, where K is the spring constant, S is the change in length, and then mg. So that's just F net explained. Then we have the energy principle, which shows the systems will change. The change in energy is the sum of the work done by the surroundings and the thermal energy exchanged with the surrounding, which is delta E system is equal to work surroundings plus Q. And then finally, we have the position and velocity formulas update, which is derived from Newton's second law. So we have the final position is equal to the initial position, added with the average velocity and delta t. And then we have the final velocity is the initial velocity plus F net over the mass times delta t. Okay, so going into our observational model using tracker analysis, so we had the object's mass was 0.402 kilograms. And from my tracking position, I found this initial position was minus 0.701 in the x direction, minus 0.632 in the y direction, and 0 in the z direction, with an initial velocity of 0 as I started from rest. And then using the data that I was able to find, I was able to solve for the time period using the time period formula. And then I was able to solve for the spring stiffness, which is K, and then the relaxed length. Okay, so in my computational model, which I was able to use from my tracker analysis, so I took the data points, put them into Excel, saved them as a CSV file, and uploaded them into my code to enable myself to get a graph. So as you can see, I have my mass, just as I stated in the previous slide, my position vector, my velocity vector, and then we have the gravity on Earth, which is 9.8, and then the spring constant and the relaxed length that I calculated. So as you can see here, a lot of these are just kind of the energy equations that we were using before. So kinetic energy, gravitational potential energy, spring potential energy, and then the total energy, like I drew on the second slide with all the formulas. So these were the graphs I was able to take away from my computational model, which they follow a pretty decent line and they're very consistent with what I would expect. But possible errors with computational and the tracker analysis is the system that we observed was an isolated system, but in reality, it's not going to be that way due to air resistance and other external forces. So our results may change slightly. And also when inputting my center of mass in tracker, I may not have been exactly in the center of mass, which would have altered what was actually my values. So a key question was, is the energy principle satisfied in this model? And the answer is yes, because to satisfy the energy principle, the change in energy must be equal to the work done by the surroundings. And then since there is nothing acting on the system as it's a closed system, the change in energy must be equal to 0. So in the graph, we can see that the change in total energy in the system remains constant as 0, which is the orange line that's going straight through the middle. And then this is because kinetic energy is equal but opposite to the potential energy of the system. So thank you so much for watching my lab, and I hope you learned something.